Hi and welcome, ladies and gentlemen. Today we are talking about depth first search in graphs. So let's get right into it. Well, when we do depth first search, we go through the whole graph and we traverse all the childs, and then we traverse the next or the first child, then we traverse this child, its child, and so on. So here we want to start in this graph from A and we want to search for the value f. So what we do first is we go to A and check, does it have the value that we are looking for? If so, we can return and say yes, it does. Otherwise, we keep searching. So A is not f, so we go to B and we figure out B is not f either. So here we can stop because B doesn't have any children. So we go further to the next child, and that is C. So from C on, C is not the value, so we keep going with the first child of C, and that is D. And then when we are D, D is not equal to F, so we go here to E. And what is the first child? And then E is either not F, so we go to F, and then we find our value F. And then we have traversed our graph and we found the value F, so we can return true. So what we are basically doing is we check if our current node has the search value. If not, then we traverse the first child and then so on. Traverse the second child and so on. Alright, let's implement that in Python. For that, I create a new Python file and I call that dfs graph.python. Well, and here I want to use the source code of another video, and as usual you find the source code also in my GitHub repository, and that source code is of the adjacent matrix in graphs video. I blend the link in now so you can have a look there if you didn't watch it yet. So I'm going to copy the source code, and that is everything here, and then also the main method. And here I want to call g.print what prints my graph, and I want then to say something like that's first search, and I want to give it the node A and I want to give it the node F. So here we have the same graph as we had in our example. So what we have to do now is we have to insert our that's first search method. So we go in and call dfs, and that gets the self attribute as usual, and it gets the start node name and it gets the search value. And then we can say here searches in the graph with that first search. Returns true. Let's make that a big T. If the value was found, and otherwise it returns false. So, and here I want to call a helper method because we want to go with a recursive approach through our tree in that first search manner. So here we call self.dfs recursive, and that gets some arguments, and actually this method will return true or false if it was found. So here we can say return the value that was returned by our recursive helper method. And let's also make this private because we usually don't need this recursive method, it just gets invoked by our that's first search method. And then we create this one, and we call here DFS rec for these just first search recursive, and that gets self node index. That is the index of the current node. It gets a search value. It will get our adjacent matrix. Let me make here a big V, a capital V, and then it gets the adjacent matrix. And it will also get a node mapping, and this mapping will be from index to node name. So we say here node mapping. And then for now, let's just say pass here. We will implement that in a second. At first we need to get the index of our start node name. So we say here start index, which will be the index of our adjacent matrix, and there we go in and say it's x.index for each node. So here we call it x in our self.nodes if x.name equals x.index. And it says this was not closed properly. And we will find out later why that was. Alright, so once we have the start index, we also want to create the adjacent matrix, and we have already a function for that. And we call here self.getAdjacent matrix. And we also need our node mapping, where we make a dictionary, and that will map x.index to our x.name for x in self.nodes. Alright, so good so far. And then we can here give our DFS recursive the start index. It will get the search value. It will get our adjacent matrix, and it will get our node mapping. Alright, now we can go in here in our just first search recursive method, and at first we say if our node mapping of the current index, and that will be node index, is equal to our search value, then we say return true. So if the current node that we are working on has the value, we can say return true and everything is fine. Otherwise, we have to go through all the children of this node. So for I in range adjacent matrix, which gives us the elements in our adjacent matrix, and adjacent matrix are always squared matrices. So it doesn't matter if we have a look there for the actual line we are looking for, or if you go and take the length of our adjacent matrix, it will just give us the length of the first dimension. Alright, so when we are here, we have this I, and now we can say if our adjacent matrix of node index and I is not equal to 0, or is not equal to 0, because we write 0 in the adjacent matrix if there is no edge. So we go in and say here then our found will be true or false if we found something. So we say we can invoke here the recursion again, so self.__, and we want DFS rec of I in this case, which is the current child we are working on. Then we want the search value. Then we want our adjacent matrix and our node mapping. Alright, and then we say if we found something, we say return true, and then we are done. Otherwise, we go in here in our else, or out of our else block, because then we run through everything. So here we can say return false. So this will mean that we are done with our recursion. We didn't find the value, so we give false back. Alright, so let's try it out if that works. Here we already invoked this method. And here is the error, because we use here if x.name equals x.index, but that has to actually be the start node name. So now it should work. And if we run it, we print here our actual node. And we also have here to make a print. So we print what what's the result of our desk first search, and we get true back. And if we search for G, for example, then we get a false back as expected. Let's make another try. Let's say C. That is true too, and for D it should be true too. Alright, ladies and gentlemen, if you liked this video, give it a thumbs up and subscribe to the channel to always get informed whenever I'm uploading new videos. Check out my GitHub repository for the source code, and I'm really happy about every comment you put under my videos, and I like to reply to them. So that's it for me. Have a great day. Bye.